That's not good. Cassette. Yeah, cassette. Yeah, actually, something bring you from like, something to bring food back for this. It's just yourself. Okay, you don't know. I don't know. I did not want to do it. I was okay. These are like material. So actually, producing a whole lot. Material, a whole lot happening on the material. If you, I think, if you, this is your first time here, you are you're already with it, make it easy. At least we started this year with the overall activity, so we don't need to be like off the rest of the happen. We're rolling out different opportunities. If you join the serial, you notice we have icon, we have page, we have list, we have different opportunities. So if you go to that, then you spend more on the area. But some of you want to here, so it's actually well for you. Just take it seriously and try to be more research about the engage in the Telegram group. The Telegram group is good. You don't work with mentors, people abroad, and across the country. So let's try to like build a community together. Our Twitter is very handled. Our Twitter is very active. We've seen different live podcasts getting something so we leverage on these that will be known. And I think we try also to bring about into grants and stuff like that. We're just talking about the capacity handling for those of you happening in the capacity of should be submitted by tomorrow. And there's a lot of stuff around that protocol. And for those who are going to do that here, we should be able to like send a mail for those who are also in the like giving them the reward. So we should expect from the reward, the reward, so what PNX like just having a high day. If you have a wallet, so be like PNX. Shouldn't get any pictures, so keep support like that. So even those who saw it, so these are some of the stuff we're rolling in the community. So just take advantage of all you were free able to benefit the end of the year. We have the change level, this is the basic call. Share will be doing the well. I don't know if it's there, it's not there, it's very good for everything. We have my friend here, that is here, of the government, so who also like, oh, still wants to go. We would like to come along. I think we can get, go to, let me look at. So as we studying, we were talking about your shoes, so don't, I stop the class. Just,
Let's take it down. All right. Good afternoon. Yeah, good afternoon, guys. My name is Uchi. I'm a smart contract developer, blockchain developer, and I'm also a student. So, we're talking about bees today, and we're talking about the blockchain in general. I'm a developer, so I'll be partial, and we'll look at it from a developer's perspective more than a user's perspective. Well, before we start, if you know anything about the blockchain, just give me a wave. You know anything about the blockchain? If you're not hearing blockchain for the first time today, just okay. I can assume we all know what the blockchain is now. Okay, if you've heard about layer 2, okay, it should be fun. All right, so this is our agenda for today. We'll be looking at an overview of what the blockchain is, why we need the blockchain, and what we can do as the as a blockchain user. I'm looking at it from a Nigerian perspective. Why is the blockchain important to us Nigerians? What does it unlock that we don't have 5, 10 years ago? What does the blockchain make possible for us Nigerians? Then we'll look at why L2s. So L2s just mean layer 2. So we're looking at why L2s, why did people spend millions of dollars building L2s? What value proposition does it bring to the table? So look at one kind of L2 as an optimistic L2. We'll look at what it entails and how it concerns our life. Then we'll look into smart contract development lifecycle. That is just the stages from the idea stage to execution of a smart contract project. Then we'll have a hands-on session where you do your creativity and build something, something innovative, I hope. Then we'll have a feature of base discussion, and this should be handled by Sean, who'll be here soon. And of course, we'll have some networking sessions and Q&A opportunity, Q&A. So let's dive right into it. So forgive me, I imagine this would be more coding, so I didn't have a slide. So, well, anything I'm saying is going to be coming from my head, and hopefully it's correct. Yes, so we're starting off with the first one, an overview of the blockchain. So what is the blockchain? So my personal definition of the blockchain is simply a network of computers that agrees to the state, so a particular truth. So having 4 computers agree that Uche have $10,000, that's what I imagine a blockchain is. So a much more dictionary definition of a blockchain is a network of computers that are in consensus and are fault proof, and they are consensus in consensus, I said already. So So, forgive me again, I don't have a slide. So, a blockchain is a system in which a record of transaction, especially those made in cryptocurrency, is maintained across computers that are linked together in a peer-to-peer network. So that's like the dictionary definition of a blockchain. So all these are stories. So this one is not my business. So as a Nigerian, I am more important, or what's more important to me is what can the blockchain do for me? So we are all students, and we know to a large extent that Africa, Nigeria have been cut off from the financial economy. So my own definition of the blockchain that I would accept is what can the blockchain do for me? So I would define the blockchain as a system that can permissionlessly destroy the concept of borders in financial systems. So I work remote and I work for a US-based company. They pay my salary in cryptocurrencies. I don't need to go through Western Union. I don't need to pay unnecessary taxes for ECOWAS, whatever. And my money comes in complete, untouched in few minutes. It's in Naira. So that is my own definition of the blockchain. So are we on the same page, or this definition is just so special for me? All right. So I think that's fair for an overview. So let's just look at the blockchain as a system of computers. You can't just stop the blockchain because it's geographically dispersed and they all agree in a state. So just take a state as account balances, just the way our bank track our account balances. So all this network, if I ask the node in Ethiopia, what is Uche's balance? He says it's $10,000. If I ask the one in Egypt, what's Uche's balance? He says $10,000. All the computers agree on Uche's balance. So just let's see the blockchain that way. So now, why L2s? So it's a classic distributed computer problem that throughput is not so easy to attain. When I mean throughput is like how much transaction per second can the blockchain handle. So in Nigeria, we estimate that we are almost 300 million persons. Let's imagine half of us, 100 million, no, like one quarter of us, 100 million, use internet for money bargains. So we can imagine that in a day, there should be up to like 10 million requests to transfer money that is hitting one bank, let's say UBA. So if you want to move this kind of traffic to the blockchain, there's going to be a problem because the blockchain is distributed. There's not just one node. So anybody that is tracking the balances of these millions of persons need to have huge compute, huge network bandwidth to handle this infrastructure. You know that was it's not easy when it becomes many persons. So that is the concept of scalability. That's where the concept of scalability comes in. How do we make this blockchain infrastructure available for millions without having to trade off centralization? And we have the same banking problem where a bank manager can just freeze my account and I cannot access it. Or we have now security issues because we are trying to make it so fast to accommodate everybody, and there's a cryptographic flaw that is exploited and millions is lost to hackers. So now that is where L2s come into solve. So L2s is layer 2s. So layer 2s are scaling solutions. So if you want to write this down, layer 2s are two types that we know of right now: optimistic rollups and ZK rollups. So ZK is just an acronym for zero knowledge. So optimistic is what we are discussing today, as base is an optimistic rollup. So an optimistic rollup agrees that whatever happens on the layer two of the blockchain is true or less disputed. So just imagine it this way. There's the normal blockchain, we know. This blockchain is slow, it's not so fast. But there is another layer that can handle thousands of transactions without crunching. But this layer will need to report to the big boss that all my accountants, all the accounts have been manipulating. I did it in the right way. I didn't make someone a millionaire overnight, or I didn't make a millionaire a beggar overnight. So that's it for the L2. So the L2 always reports to the L1, which is the main chain, in this case, Ethereum. Um, yeah, so that's for optimistic rollup. So now, why did I say we believe that the optimistic rollup is always correct unless disputed? So all the transactions now happens on the optimistic rollup. The optimistic rollup reports to the main network. But what if the optimistic rollup reports a wrong content to the main network? So that is where the disputing can happen. Perhaps it's me. Maybe I transferred $1,000 to that network and I use it to do some stuff. And now I'm going back to my main network and they say I don't have money again. So that dispute will then be resolved on L1 and they will give me my money. So there is no concept of, or there's no big concept of centralization in that sense. So that's like the overview of an optimistic rollup. So much more boring talk, permit me. So base and optimism, they are both optimistic rollup. And as software developers like to do, anytime you are repeating something twice, you just make a stack that people can just take and redo it instead of writing it from scratch again. So that's what introduced the OP stack. So I dropped a link on the chat if you want to look into it. So that link just entails how you can be a developer that can build an optimistic rollup. Should it be a contract from a client? You want to build an optimistic rollup for this client. It has a step-by-step process you follow to understand the OP stack and how to build an optimistic rollup. So that aside, I think we are done with anything overview, and we can go into the fun stuff now. So I assume we know it's an hands-on session, and we'll be judged by our submission. So let me just give you what you should be expecting. So we will be building a smart contract and deploying it to Base, testnet. And but before we build the smart contract, not everybody here is a smart contract developer. So I want to like introduce you to how smart contracts should be built. So that's going to take us to something I'll call the smart contract development lifecycle. So that's what we'll be doing now. So first of all, is everybody following me? I'm not just saying gibberish, I'm feeling myself. Okay. So first, I want someone from the audience to tell me what a smart contract is, so I don't assume. If someone does not raise their hand, I'll point. I'll point in 3 seconds. Okay, the lady there. What's a smart contract? Yes. What's a smart contract? You know I'm talking to you, Ari. Yes, yes, you. All this smart contract is not hard, it's not hard. You can Google it. If you don't know, you just point somebody, that person that offended you. I saw that coming. All right, bro, what's the smart contract? Yeah, you can Google it. That's all right. So that's the correct definition based from Google. Yeah, so a smart contract is, as I said, a computer program. But it's not just a computer program now, it's a program that follows a certain pattern that can't be broken. And it's public. If you don't follow the pattern, everybody will know. So how is this important to us? How is it important to the financial system? So take, for instance, Netflix subscription. If the month runs out, they take out 3 to 4 thousand for your bank account for your subscription. So if a smart contract is handling that, there are going to be these few steps it's going to take. Take out the money from your wallet, record that you've paid for this next month's subscription, and show the world that yes, which you have paid for is subscription. So just see a smart contract as an agreement between two parties deployed to the blockchain. Remember, the blockchain is immutable and it's public. Anything that happens, everybody knows it happens. So this contract of agreements that I have with Netflix, that by the end of the month, talk to my wallet will give you $3. So that can be an example of a smart contract logic. So smart contract logic is Turing complete, meaning that anything you want, you can place it in there as far as you can pay the gas. So yeah, we'll be looking at smart contract design logic, development life cycle. So we just see how do people build smart contracts? All right, we'll be using a simple staking contract for the example. While in the hackathon, that's what you guys would submit for the prizes would be anything you can think of. It could be subscription service, it could be a token that's currency for one imaginary country in your mind. It could be anything you want to think of, but we'll be using a staking contract. So you see a staking contract as a savings contract for our example, and we'll see how smart contract is being built. So when building smart contract, we have 5 major stages. That's the smart contract design and concept evaluation. So that's where you think of what you want to build. So now I want to build a saving contract. So I know you'll place in your money inside, and maybe by the end of the month, I'll give you some percentage as profit for saving your money with me. And I use your money and go and do business. Then we share the profit. So that's now the concept. And like we have the concept now, we want to evaluate this concept. So in the evaluation stage now, we're saying, is this thing feasible to build? Why should we build it? Can it run perfectly on the blockchain? What kind of gas fee will our users pay? So that's the evaluation stage. The next step is now we are sure that we want to build this thing and we have a plan on how this thing is going to work. So we're going to do something called smart contract interfacing. So that is now saying, this is the functions that will be in my contract. This is the state variables that will be in my contract. I know I'll be saving the user's balance. I know I'll be saving the rewards they've accumulated. I know I'll be saving their withdrawal. So that is what happened in the interfacing period. So the next step is developing this contract. Now we know all the functions that will be in the contract. We know the state variables. Now we have to write the code for this contract. That's what happened in the development stage. So the next stage is testing. Now this logic we've written to take people's money, are we sure it's safe? Because if you lose the people's money, some people don't live to tell the tales. So we need to test our logic and be sure that everything works fine. So there won't be trouble in the future. So there are two major types of tests: unit tests and integration tests. So unit tests takes those functions you've listed, isolates that function, and make sure that logic in that function works fine. So I'll go again. Unit test takes the individual contract and individual functions, isolates it, test that function's logic. Maybe that function is just take money from address A and send it to address B. So that logic is just going to be tested on, oh, the money left address A's balance and address B has that same amount. So that's for unit test. Why integration test is now testing the full flow of the smart contract. So an example of the flow is going to be the saving flow. So the first thing to do is get the user, register the user in my contract, take out the amount they want to save, tell my contract that they have saved already, and compute their reward and how much reward they will get per month or per day, however the case may be. So that's for integration test. So the next is deployment. So now I've tested everything on my local machine and I'm sure my code is working. So the next time is to push it to a network. Most times you push it to a test network first before you push it to a main network. So in this step, we'll be using base as is base we are talking about today. So first things first, we need to access base. That's access one of these computers that runs the base network. And we'll be using Alchemy. So just quickly, I want to show you guys how you get your API keys so you can deploy your contracts on base. So this Alchemy. So just visit this website, alchemy.com. Then you sign in. Let me drop this on chat. Is everybody here? Yeah, you hit the alchemy.com. So just sign in. I'm already signed in, so I'll just go to my dashboard. Are we together? We've logged in. All right, so next up is to create an app. So with an app, you can have an Alchemy private key, or that's like an API key you can use to talk to the network. So how we just do is we just click on create app. Now we choose the network we want to talk to. So we want to talk to base. So we click on base. So far we're on the same page, yeah? Alright. So from the home, you click on app or apps. You've all signed in, yeah? Okay. Okay, let me just use a new browser. All right. Yes, very simple, yeah. If we are in this place, just wait, let me know. Yep. I need more hands. What's happening? Why are we not here? You can name it anything. So we're choosing the base network as that's the chain we want to build on. And we'll choose base Sepolia. So this is the test net for the base layer 2. So create app. Now I want you to go to this place, API key. Then we do one for the HTTPS protocol. Just copy it and just save it somewhere. If you need help, just wave, I'll come a bit. All right, are we on the same now? Yep. Are we on the same page now? Have we gotten it behind? All right. So we'll be using an remix. If it's talk about that, the FVM class. But later on, just to add that and if you want to do smart contract development, so that's more like the key we use for professional development. But for now, using because it's much more easier and not all of us do smart contracts on it every day. So just click for Ethereum Remix. The ID will pop up and we can play. Ethereum Remix. Just showing that search query.
But what I feel is that I will be available at the government. Yeah.
So, when you create,
It's very interesting now.
just use a new browser.
Is this your system? Okay, so don't worry about it. Sort it out. For your you give feedback. Someone is going to
So if you are creating this for the first time, if you are using Remix for the first time, you just accept all these pop-ups.
Is that right?
So this is the section that is important to us, the contract section. Okay.
Yeah, something like that.
I think it's from mine. All right, I think we're good now. So I want us to create a new file here and we name it staking contract. So just a full disclaimer, I won't be teaching you how to write smart contracts. Just look at this like just a YouTube video or Indian guy just put one project along. As much as possible, I try to explain I think you don't get, but you have to do much more research if you want to go deeper into smart contract development. But besides, all the resources I have after the session, I'll drop them on the Telegram group chat. So we can go back to our mini curriculum. So the first stage in smart contract development, smart contract design and concept evaluation. So we want to build a staking contract where people can bring in gas, and every month they can receive 2% of their initial deposit. So that's what we're trying to do. So now what do you think should be the design of this kind of contract? I don't mean you should tell me stuff, because what do you think will happen in this contract? The depositing stages, the withdrawal stages. You have two functions, three functions: deposit, withdraw, and claim. So the claim is just whatever percentage I've gathered as time goes on, I will just take it. So somebody just raise your hand does it should work. Yeah. Yeah. Mm-hmm. Yeah. All right. That's cool. So, as I said, the deposit is just going to take in who is depositing, how much is depositing. So, so next time when you come back and say, I have deposited $1,000 worth of it, our contract knows that yes, it's true. You have deposited this and you can withdraw it out of the contract balance. So, that's for the first function. So about the withdrawal, someone else tell me about the withdrawal. How do you think the withdrawal should look like? What happens in the withdrawal function? Yep. I will point. Yeah, I'll verify the balance, yeah. Yep, that's it. So the last function, the claim function. Yeah. True. That will happen when your MetaMask pop up and you just sign that yes, I want to withdraw. So the last function is the claim. So how should the claim look like? The fair guy that is enjoying the AC. Yeah. 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 True. So now we've gotten these details. The next step is interfacing this contract. So now we know the three functions are going to be in our contract and we know what it's taking. So we will now interface it. So interface is just like we're drawing like no when you want to build a house, you have a house plan, your surveyors or your architect drew for you. So the interface is just drawing the plan for this contract. You know we have three functions and whatever we build must adhere to this interface. So in Solidity to create an interface, we use this word called interface. Yep. And we name it whatever we want. So it's a convention. Okay. It's a convention in Solidity that whatever interface you are creating should just be the name of your contract, but have so in Solidity, the name of the interface should be like the name of the contract with a capital letter I in front. It's just a convention, but you can disobey it if you want to. So this is what we call a license identifier. So this just tells the public what you could do with this smart contract. So this GPL just means it's free and there's no string attached. So that's for that. So this is now specifying the version of Solidity. So this just specifies that the Solidity compiler can be from version 0.70 to 0.90. Less than that's around 8.9 whatever. So this just specify what version of Solidity compiler should be able to run this Solidity code that is going to be deployed on chain. So from our interfacing, we know that there's going to be three functions. That's the deposit. There's going to be a withdraw, and there's going to be a claim.
But this thing one do is 10 minutes.
So now, in Solidity, the way you interface a function, you just write this keyword function, the name of the function, so this function is going to be taking in like parameters of one, the person deposited, and two, the amount the person is depositing. So the way we identify users on the blockchain is by addresses. So this is the address of the person depositing and the amount that is being deposited. So when creating interfaces, all your function must be external. Just like the visibility identifier, now they call it, just double the that this function is public. So anybody that sees this function and all the deposit function and the function acknowledge that. So there are majorly four visibility identifier. External. So this means the public can access this function. There's public. So external means the public can access this function, and any function or any contract that inherit this contract can also cannot access the function. Or public, the public can access this function, and any contract inheriting this contract. I know this is gibberish now. So just look up visibility identifier solidity. That should explain it. Alright, the next function is going to be the withdraw function. So still following the normal pattern. So now the withdraw function is taking a different turn. So we want to know the address that this withdrawal is going to be sent to. So this initially deposited ETHs. Which address is it going to? That's what the withdrawal is going to take. So we're not asking them for the amount because we already know the amount they deposited. So if we ask them, they could lie, and we don't want them to lie. So we ask ourselves because we trust ourselves. This is also external, and the last function is claim. So when we claim, so the claim function now will take in the address that the amount that is being claimed is going to go to. So let's say we made up 20% of $1,000. So this claim function, when it's called, by putting the amount that this $200 is going to be sent to, that's still going to be to make this external, and that's it. That's now we're done with the interfacing. So this is how simple it is. Or this is how simple an interface can look. Next thing is going to be writing the code that's going to run this smart contract. Are we having any trouble so far? Yeah? Having trouble.
Your license expired.
So just put one on this picture. Right, so we go to the next step now. I'm writing this contract.
What's just
This taking contract. So that writing this, we've interfaced it. We are going to deposit. We are going to withdraw. We are going to claim. Now we want to write the logic that will handle the deposit, withdraw, and claim. So in Solidity, to create a contract, we use the contract keyword. That's contract. Then the name of the contract we want to create. Taking contract. So now we want to impose or want to force our contract to follow our interface. And that's the whole point of having an interface in the first place. So force a contract to follow an interface. We use this keyword called E. That's IS. And we place in the contract, the interface name. So once you do this now, you see errors in your contract. So if you look at the error now, it says this contract should be marked abstract. It says this because this contract does not have these functions that the interface is imposing on the contract to have. Now, to get rid of the errors, we have to create each of these functions. So that's the importance of an interface, to make sure you abide by the design you have created in the first place. So let's swing. All right, so once I create all these functions, though there's no logic inside. Working on the deposit function now. So first thing, we are depositing ethers, and we will be giving in our rewards in ethers. Now, for a function to accept ethers, you need to mark it as payable. So, like when they call the deposit function, the function should be able to receive ethers. That's the currency we're working with. You need to mark it as payable, and we'll mark this guy payable. So now it's going to complain because our interface didn't imply that this should be payable. So all we just need to do is to come here and make it payable. And it should be good. So now before we start writing the deposit function, we need to like track some data that we're going to use in the future. So one of those data is we need to know how much a user have deposited. We need to know how much a user can claim. And we need to know how much a user have claimed. So we need to create something called state variables. So state variables are normal variables that we know in another programming language, but this time around, it's stored directly in the blockchain, and you can only access it using the logic in this smart contract. What I mean by access, I mean you can only modify or read it using the logic specified in the smart contract. So first, we need to create a register that will register the user's address to how much they've deposited. And classic programming would say we use a mapping to implement that. So we create a mapping. So a mapping is just one of the data structures in Solidity and exists in many other programming languages. You just see this as a dictionary in Python. No, I think of what it is in Python. But as for that, a mapping is just key to value. So give me any key, and I'll give you the value that corresponds to that key. So this mapping now to track a user's address to the amount deposited. So address is going to be here. I am having memory crisis. Don't mind me, somehow I've forgotten how to define a map. All right. So, yep, address. Okay, then you took the 6, yeah? Okay. Whoa. Somebody help me out, Abeg. Is this correct? To define a mapping. Okay, it's correct. Right. Now we have our mapping in state. So now we can track our user's balance. So given a user's address, I can know how much this user have deposited. So now we want to track, we want to state the percentage that the user can get after a certain period. So let's use 10 seconds as a period so we can like test it live. So we want to store a variable that says the rate of the dividend is 10. So we just create a UX. Well, let's just use Unity 6 so we don't have any time issue. and we'll name it rate. So after every 10 seconds, the user can claim 10% of their initial deposit. So now this is cool, but we're not changing the thing throughout the life cycle of the smart contract. So it's safe to say we can leave this at a constant. And this is going to save us some gas. So constants are stored directly in Python. That is what you get after compilation. They are not stored during runtime. They're not stored on contract storage. So it's just triggers to retrieve whatever you store in constants. That's this, if I remember. So I think we've gotten the state variables we need for writing the deposit function. So now we can go ahead to write the function. So now, okay, let's add one more. We want our minimum deposit to be 1 ether. So this is the minimum deposit. So if you want to save in my bank, you need to save at least 1 ether. That's just what we want to imply. So now in the deposit function, the meaning of payable means that the user is going to in the transaction they're making to this contract, calling the deposit call, they attach some amount of ethers to that function. So now I want to know that amount of ethers that is part of this transaction payload. So the way you access that is an environment variable. So the way you access that, we just use MSG, that stands for message dot value. So this gives us the amount of ethers that this user sent at the payload to this function. So we'll be storing that in memory. So we just create a variable called 56 sending value. So this is how much they sent in. So now we know how much they sent in. Remember, we have a variable called minimum deposit. So once we're sure that they deposited at least 1 ether, so are we following so far? Okay, I think that's good for now. So what we would have to do is just going to be a simple if else statement. If this user deposited up to 1 ether, let's proceed. If not, revert this transaction. For in Solidity, we have a shorthand for that. It's called require. So a require statement takes in a condition that's true or false. If it's false, then this revert statement or revert message is going to be in the error log of that transaction. So this is what we're going to use instead of writing if or else. So we are running out of time, and I'll make sure we finish by 4:45. When I say finish, I'll make sure I stop talking. by 4:45, so we can like get into what you need to build. That's the purpose of this long talk. So I'll not talk for a while, or I'll not talk that much. So now we want to check our minimum deposit. We want to check that this value that's sending in is greater than or equal to our minimum deposit.
So without that, we can send don't share it out just for you. Yeah, it's time span. So don't there's no abuse because of time. Your time span. In the midnight, don't want to meet everybody. We start now. We check it. You know what? This time to do. Whatever you look for, because it's not.
All right. So that form, that's whatever you scan like the form, the own form, will not send you a link, a base list, one base list, for you to save your system. So you don't share it. We just call it stuff. The key of the area. What? The key of the area. What are we? No, just put your own. Okay, this one is our attendance. We are collecting your emails and your stuff. So now send you the base
link. Don't share it. So you just fill it up, then you receive it from them. Thank you.
Oh, okay. You want to do the centralized wallet? Okay, non-custodial, that's it. Why do you guys prefer the trust wallet? Something like a phantom. Oh, okay. I'm fine.
Hello. Hi. Right. So the thing is I'll just explain the diagram I've done on that. And we just talk about what you guys have deposited our so if you write about that, we have money from the user and we have only withdraw what is
That tracks how much a user have deposited, and that is this mapping here. So this is the source of truth
on how much so now we try to call this visual function.
How we can get the person making the contract because the value set to the contract to get associated score. And we use this variable called sender. So from the message that happened, we get the sender. That's so actually, how much have this rule deposited? So we do that in this case. So perhaps you are deposited one salary. We get that value and we send that value to this address. So this is not self-explanatory, but this is the thing that send that to this address, and this is the amount of the pattern. Amount of that really moves from that. But think that is that from now, it makes sense, you know, the direction. So that's it. That's it. So I just picture you how you find the ability to contract on these statements. And so you can talk about what that means to the analysis and what you do about. So there's this compiling and selection. So you see this green tick here shows that it compiled successfully. So when you want to deploy this, to the base network. Let me just move this to my other image. All right, so we've compiled. So now we want to deploy. So just follow these steps so you can deploy on your own. If your contract is TMT, just do it. It's going to work. So I'll just be sure you understand the deployment step. Okay. Yes, good, yeah. All right, so when you are deploying, my preference is deploy locally first and be sure whatever you are doing is working. So we just hit deploy. Okay, now we select the contract not to deploy. You cannot deploy an interface, so you select a contract and we deploy it. So this is on my local machine, and we see these functions are available. So our deployment is successful. So we want to deploy this on base testnet. So first thing you need to do, I want you to go to this website, chain list. I want you to add the base test network to your MetaMask so you can use it to deploy. So just click on include testnet, type in base folder. So we add this to MetaMask. Yeah. Yeah. You have to deploy it one after the other. Yeah. All right, so switch to the base network. So now we need testnet tokens, and I don't have any. So okay, I think I have some. It's not really money. All right, so go to this just type so when you type base supply process, it's going to take it to the base documentation. I prefer using Alchemy because we've all created Alchemy accounts. So it's easier to get test token from there. So when you get here, you place in your development wallet address here and send me it. All right, so the chest token is going to go in your wallet like this. You need to sign it.
I'm trying to switch it.
Close this first. All right, no, click on this. Yeah. Scroll down. Pick your MetaMask. You added the wrong node. Add that to get rid of it. What you need to do is to get this out, then add this to your network.
Yeah, you don't use my you can guide me, sir. Yeah, no, I don't want to guide you.
Sorry.
Have you sent you term or the so don't see we very using a level that in a term or so those is
This is the last. Let's just do this last stuff and we are done. So we deploy this locally and it works fine. Once we deploy it to a test network, that's base in this case. So to deploy with Remix, we have to use injected Web3. So just click here and click on injected provider. Normally, you pop up your MetaMask if you're not connected. For this portfolio.
Yeah, like that. Can't detect it.
Okay. This is the Remix. Let me try and run this up first.
What about
Base BuiDLing. Let's try that now. Oh, there's no process for BuiDLing. That's the problem for that network. Yeah, I think it's base network, not Remix. So let's just deploy this on another test network, Sepolia. So we can just see that the deployment flow is working fine. They're not hacking again. Do What am I doing now? So that's I should wrap up the session in like 2 minutes. All right. So we're about to wrap up the session. Yes, yes. We deployed with another network, Sepolia. Sepolia is kind of down right now. So just use the normal Sepolia network with ID of 1100, 55, 1100. So now let's just talk about your assignment quickly before the next speaker comes in. So, hello. Yeah, let's talk about your assignment quickly. So the submission is in 24 hours, and the stop your building. So you are submitting a GitHub gist to the smart contract you built, the transaction hash, a GitHub gist, or a GitHub repository. Okay, so the deployment step again. You go to the practice, once your contract, you save, it will compile. Then go to this deployment you scroll up and choose the network and choose your provider. Because you want to deploy it to a real network, not locally, you need to get the provider. And to choose to take the network that are currently connected on a MetaMask. If you want to switch it, just look at MetaMask and switch it. You can use BuiDLing, you can use Sepolia, you can use BuiDLing. All these are test networks. But for your assignment to deploy it on this test network, hopefully the RPC is going to be all provided. So after you set up this and you can see your balance, yes. What you just do is compare, click on the contract and install it. And you can choose the contract, not the interface. So for this assignment, I get my language of business for the contract review. The person when you deploy the contract, so the transaction hash when I deploy this contract is this guy. So this is the transaction hash. Oh, it's the same thing. So this is the transaction hash when I deploy this contract. So you send this in, and then you interact with this contract. An example of an interaction is going to be the deposit. So let's just do the deposit. I want to deposit, let's deposit 2 Ethers. guessing this should fail. But either way, send it. Ash. I don't have enough gas to pay for this, but you should be able to. How you will do that is you go to your smart contract and you change the minimum deposits. We change it to something smaller. You can change it to
0.1.
no, Way is like Vitas is 1:18. Go is 1:9. So Go is way much lower, and we should be able to afford Go. So you send me the transaction hash from your interaction. Yeah, on whatever you do. So you send me a GitHub gist or GitHub repo, the contract creation transaction hash, and your interaction hash. And that's everything. So before I get home, I'll send all the resources you would need to the Telegram group chat. And you can just play around with it. The phone will be open for 24 hours from let's say 7 p.m. GMT, GMT plus 1, whatever. That's 7 p.m. The phone will be open from 7 p.m. to 7 p.m. tomorrow for submission. So I think with all this viewpoint of mine, this will be the end of the session. Yeah.
Sorry, I have a few questions I've sent in the chat. I don't know what the assignment is or where the form is. Is it that they will be sent later?
You want to share something?
Yeah. So this really the first has all right. So then you do that. What are you doing now? What should we have? Nigeria. Oh, wow. Hey, can I just yeah.
No, I just need to start the recording and it's finished.
Post something,
Yeah, I think.
start serious and calculus. Post something else, start serious and base. Exactly.